All right, guys, I'm back with another video. So I'm just going to do a real quick rundown on the traversal system. I'm not going to go into depth on all the details of the logic behind all of this because it would turn into probably like an hour-long video, and I really don't want to spend that kind of time on it today. If you guys do want a more detailed one, then let me know. If enough people want it, then I'll do it. But I'm just going to go for the basics. There's one important thing that you need to know about this because they're doing pose searches against the Anim Montage based off of the database that's currently loaded and playing. And that was confusing for me. And I think a lot of other people will find it confusing too because it's not very intuitive how it's supposed to be done. So I'm going to explain that to you. So anyway, they go to jump, and if they're not currently traversing something and they're moving on the ground, then they can try to traverse. If that fails, then they can jump. So they're doing a forward trace, which scales with the velocity and direction of the character. And this right here, they use it in ALS, but it's basically the same thing. What it does is it reorients the velocity to be pointing in the direction that the character is facing. A lot of people get confused by this because the Y is actually the forward direction, but whenever they unrotate it, it's the X direction. Well, the character movement component's forward direction is the X direction, but you'll see that this mesh's forward direction is actually the Y direction. But we have to rotate it -90 to orient it with the character movement component. So anyway, so they scale the value, they remap the value of the X, which is the forward direction, to be between 0 and 500 because the run speed's forward direction is 500. Its left and right direct speed is 350, and its backward speed is 300, I believe. Anyway, they have the other ones here too. They have not added sprint yet, but they'll be adding that in 5.5. So moving on, they're remapping that. So if they're not moving that, then the trace will be 75 centimeters in front. If they are running, then it'll be 350. And if they're somewhere in between, walking or whatever, then this value will scale accordingly. But it'll be pointing in the direction to trace. Anyway, they're coming in here, they're doing some traces. They're tracing to make sure that there isn't any obstacles. Well, they're tracing for a level block traversable actor, which is this right here. They have these ledges right here, and these ledges are splines, and these points are manually set. They're not setting them procedurally, as far as I can tell. It looks like they manually place each of these, but I could be wrong. Maybe they just didn't add some tool they used that does it for them. I don't know. You'd have to ask them about that. But the important thing to take away from this is this little half circle here with this line going across. That line is the normal direction, and that normal direction has to be pointing out from the ledge. If you orient this in any other way, it's not going to work properly because they're tracing against that normal. So after they've confirmed that they have hit a level block traversable actor, they have this right here. This is actually a local variable. The reason why they're setting it by reference, setting the member. The reason why they're setting the member right here is so that they can just choose what gets exposed. Otherwise, if they were to drag it out here, they would have to split it, and they'd have this big ugly thing. So it just looks cleaner to do it like this. So they're actually passing this local variable in by reference to this function, which exists on the level block actor itself. And so if you double click this, it'll take you to that function inside of that level block actor. And it's just, it's setting by reference the values of that structure, that traversable check result structure. And they're doing other stuff here. This right here makes sure that the location is not going to be hanging them out in the air. So that makes sure that, for example, that it doesn't return this location right here, because if it did, the character would be hanging half out or half off the ledge. It would only be grabbing it with one hand. The other one would be floating. That's not something that they want. So, I mean, obviously. So anyway, that's just a quick breakdown on that. So anyway, they move on down here, and they're doing, they're performing a check to make sure that there's room between where the actor is and the ledge for them to traverse up to the ledge. I've kind of made notes here on mine. You're not going to see these notes because those were from me. I wrote those down as I was going through here working out the logic. So anyway, they do another trace right here to make sure that there's nothing. Let me just show you. So they'll do they'll do a trace from this ledge to this ledge over here. And if something is in the way, then it'll act accordingly. And that's what this is right here. So if there's an obstacle in the way, then the depth of the object is from that ledge to whatever object it hit that was in the way. And then over here, if there wasn't anything in the way, then they'll do a trace down from that ledge to the floor. And the reason why they have to do all that is because they have three different types here. So they have vaults, they have hurdles, and they have mantles. So a mantle is just where they jump up, grab it, and climb up on top of it. A hurdle is these narrower ones where they just jump over it like it's a hurdle on a track field. And then a vault is, well, it's where they run and jump and kind of go sideways up it. They don't actually grab it and pull themselves up. They just kind of hop up on it. That's what a vault is. So then there's some more debug stuff. Now over here, if these values were such that the variable, the action type was set to none, then we will fail to traverse. If not, then, okay, this is what a lot of you have probably been waiting on. So they set the interaction transform right here, and that's based off of the ledge location and normal. They turn the normal, which I told you was a direction, and that direction is, if you made these right, that direction will be pointing along that line. It'll be pointing away from the ledge. They turn that into a rotation, and they send that to the blueprint interface interaction transform of the animation instance. So if you pull this up, you'll see over here the interfaces. You got this get and set, and that's part of that BPI interaction transform. It's just got a setter and a getter in it. And your, let me see, your pose search in here, it uses a specific, yeah, so right here, it uses a heading channel. You have a heading channel here, and it's just getting the Anim instance. It's getting that interaction transform blueprint interface, and then it's calling that function off of it, that getter, and it's setting this to the rotation. And then on this, oh, that's the heading right here. And you'll see that the bone here is set to attach. Now, I haven't completely broken this down, but I do know that if you set this to root, you'll notice that the attach is just an unweighted bone on the root. If you set this to the root, it'll do some funky stuff. Your character will go through it and stuff like that. They need this to not be the root. And I think it has something to do with, let me see. I think it might have something to do with this offset root bone because it modifies the root bone during stuff. I might come back and do another video on that part of it, but just know that on your skeleton, you do need an unweighted bone called attach, or whatever you want to name it, off of the root to actually use for this purpose. If not, it's going to cause serious problems. So anyway, so that's how they're setting that. This post search schema is used by the post search database. You'll see right here it uses that post search schema. You'll understand why we're using this here in a minute. Now, based off of that traversal trek results and the character's velocity, its total speed of that velocity vector, that's basically the magnitude of the vector length xy. So anyway, based off of all this information, they're going to pass this into the chooser, and I'll open that up now. And if we go to the table settings right here, you'll see that the input is a context data object type struct, and they set it to this structure. So you can only choose a structure or a class. So if you just need one enum, then you have to put the enum in a struct. You can't pass the enum into a struct. I mean, you can't directly choose an enum here. And you either have to access it from a character reference or pass it in by struct. So you'll see this is the struct. And if I can find it, yeah. So the output type is an animation montage, object result. And right here, they're binding this to the action type enum of that structure that we're passing in. And based off of that, we'll choose the hurdles, volts, or mentals. And if we go into one of these, you'll see these are passed back out based off of the obstacle depth and speed. And that one doesn't make it very obvious, but you'll see that some of these will be passed out together. So for example, this one has for an obstacle depth, if they're walking and their obstacle, which means that they're between 100 and 250 centimeters a second, and the depth of the object is between 0 and 25, then we'll pass out the left foot and the right foot variant of this traversal animation montage. So whatever this returns, it might return those two animations. And then we get the anim instance from the mesh, and we call the motion match, and we give it the pose history name. And the reason why that's relevant is because I guess there may be some situations where you might have two pose histories. And so you'll see over here, you can set a tag on them. And the tag of this one is pose history. So it's going to look for the one with the tag pose history. And if you look right here, that tag shows up right here in the lower right corner, pose history. So that's how you can identify it without selecting it and looking for the tag. So just in case you have two of them for whatever reason. I don't know why you would, but anyway. This right here should get set for you automatically. I don't think you need to be setting that. That's for debugging purposes, I guess. So this is what it returns. What it's going to do is it's going to search a database, and based off that database and the currently playing animation, it's going to return one of those animations from the results. Also, I should warn you, by default, this is set to first result, which only returns one. It needs to be set to all results, because there's going to be more than one in most cases. And even if there isn't, this only takes an array. It doesn't take a single entry. So if I set this to first, you'll see it's not an array. So what we have to do is we have to cast this to an Anim montage. If for whatever reason this fails, then it's because you didn't set it up correctly, or because something else happened, like your schema or your database wasn't set up properly. And I'll explain that to you, because mine kept failing and I couldn't figure out why. Because the only thing I had to go off of before was like a couple of seconds in their live stream video where they could just kind of flashed this, but they didn't actually really explain it fully. They just briefly talked about it. They didn't show this other part that I'm about to show you, and so I was confused. It kept failing. But what this is going to do is it's going to return the time. So let's say that 0.33 seconds into the animation is when it thinks that we should start playing the animation. And so that's what it'll return here. And if it thinks that the play rate should be scaled up or down so that it's playing faster or slower, then it'll return that here. And that's why they have, they have this cast, because this returns an object reference, and this requires an Anim montage object reference. So you have to plug in that cast to this. And then the start time is a selected time, and the play rate is the wanted play rate. And now you have your selected montage and animation, and you have it stored in this struct. And if we follow this over to the event graph, you'll see that they're updating warp points. I'm not going to go into this. This has to do with motion warping. You will need a motion warping component here, and you'll have to enable the plugin if you're doing this on a custom project. But you'll see that they're setting this global variable traversal result to the output of that local one. And then right here, they're playing a montage, and that's the reason why this is on the event graph, because they want to play it as an async function. And so whenever it starts, they tell it to ignore the component when moving, this component here, the one that we traced against, which would be this block right here, which is a component of this actor. And then they set the movement component to flying. If for whatever reason this is interrupted or it completes, we'll set doing traversal action to false, so that they can jump again. While they're doing it, they can't jump. And then we're gonna tell it to no longer ignore that component. And then we're going to set the movement mode to falling if we're vaulting, because if we're vaulting, that means that we're going to fall off a ledge and then we're going to hit the ground. But for anything else, we're just going to set it back to walking. Now, if you just set it up like this, it's not going to work. So I'm going to explain to you how it works. And it's a little weird. If this is failing right here to be cast as, if this isn't returning anything, or I should say if this isn't returning anything, then maybe either this is wrong or you didn't do this other step. So that's what I'm going to talk about now. So this is the part that I had to, it took me even a while looking through this before I figured it out. So it's really weird. If we come back over here to the animation, this is one of the animation montages that's in this chooser right here. So if we look into this, you'll see this pose search branch in. Now I did a video before and I admitted this motion matched branch in. I didn't know what it did. It's the pose search branch in. So if you select it and you look over here, you'll see that this database is set to the PSD traversal. So you remember we had this traversal database right here. You have to have this for it to work. This one has a different schema than the other ones. It has a pose search schema specifically for this traversal, which I told you that it was passing that information into or for. And this is a special one just for traversals. And this pose search database has to be linked to this Anim montage right here using that motion match branch in order for that. Let me see. In order for this to be able to search for a result. So I'm guessing the reason why is probably, if I had to guess, I would say that it probably has to search a database. It has to compare this database against another database in order to find the correct pose, which is why it can't just simply search it against a random montage. It actually has to be linked to a database, and it has to have a branch in notifier so that this will know what database to use. So yeah, that's pretty much it, guys. That's how that works. If you have any questions, ask down in the comments, and I'll see you in the next video.